Hi, and welcome to our presentation, our video on precipitation rates. Specifically, we're looking at rainfall rates, and we're going to be talking about point measurement. And we've already gone through in another video the early history of point rainfall measurements. Now we're working our way into accumulation gauges, and in this video we're going to look at the theory behind accumulation gauges. So first, what exactly is an accumulation gauge? According to the Glossary of Meteorology, it says that an accumulation gauge is a class of rain gauges in which, of course, precipitation is accumulated over a period of time. That's pretty straightforward. Typically, with accumulation gauges, we measure the depth of accumulated precipitation. And that can be done either manually by sticking a ruler into the accumulation gauge, or there might be a display that actually helps us estimate the amount of precipitation. It also can be done by weighing the amount of precipitation that's falling, or there may be a float that's connected to some electromagnetic device that will give you a readout of the amount of precipitation. So the accumulation gauge, of course, collects the rainfall as the rain falls, and it holds it until it's emptied. And typically, recording is done manually, usually by sight. In this case, we're looking at a standard rain gauge, and we can see the measurement in the tube, and then we'll just record that. So we'll go through a little bit of the theory and the different types of accumulation gauges. First, the theory. Of course, the accumulation gauge measures the depth or the length of the amount of water in a gauge. So how does that relate to rainfall rate? Well, we came up with an equation for rainfall rate, and that was it's the mass flow of water divided by the density of water. And if you remember, the density of water is mass divided by volume, and the mass flow rate was the mass of water through an area, a particular area, over a particular time. So if we break down the density of water and start canceling lengths out and also masses, we're left with just the height of the depth of water in a gauge over a period of time. And that's your rainfall rate, how that height changes over a period of time. So the depth we measure, of course, the depth usually in inches, at least here in the United States. Other countries, most other countries, use millimeters to measure the depth of precipitation in an accumulation gauge. And if the precipitation is falling at a given rate and it's falling over a period of time, then the rate times the time, sum that over the entire period of time that the rainfall has been occurring, then you get the depth of the water in the accumulation gauge. Pretty straightforward. So in this equation, you see that there is no area. The area we canceled out, remember before, because of the volume that was included in density, the density of water. So the area of the rain gauge opening really is not a factor in how much precipitation is measured in a rain gauge. In other words, you can be measuring using a small test tube, leave the test tube out in the rain, or you could put out there a garbage can. And assuming that the rainfall rate is the same, then the depth of water in the garbage can and in the little test tube should be the same height, believe it or not. It's not a function of the area of the opening of the rain gauge, but it's a function of the rainfall rate and the time. So this actually holds very well for short distances, looking at rain gauges that are very close together. But as you know, rainfall rates can vary over very short distances. And here's a picture of a springtime shower. And it indicates that some places are getting heavy precipitation and other places are not. And that is the assumption, that's one of the assumptions that's invalid when looking at larger areas, is that the rainfall rate is not the same. And the National Weather Service has a method for estimating the intensity of the rainfall rate. They call the rainfall rate or rain either light rain, moderate rain, or heavy, and that depends upon the rate at which the precipitation is falling. For light rain, it's 1/100th of an inch to 1/10th of an inch of precipitation in an hour. For moderate, it's between 11/100ths to 30/100ths of an inch in an hour. And heavy precipitation is more, or heavy rainfall is more than 30/100ths of an inch in an hour. So that's a little bit about the theory of accumulation rain gauges. Next, we're going to look at the different types of accumulation rain gauges in another video.